This is ASFurther Maths. We are on Unit 4 Vectors and we're deriving the Cartesian equations of a straight line from the vector equation. So what we did in the last couple of videos was look at the vector equation of a straight line, r equals a plus lambda b. This is of course a point on the line, and this then is the direction then that the line is going. The r bit is what's generated, so it generates different coordinates if you want to call them, so xi plus yj plus zk, and the a bit then is the point on the line, the b bit then is the direction the line's going. So if we fill in r, a and b into this, we end up then with this line here. If we bring together the I bits here, can you see that it's going to be I is upon, so a1 plus lambda b, so that's where that's coming from, a1 plus lambda b I, a2 plus lambda b2 j, a3 plus lambda b3k, there shouldn't be a k in there. And what you'll find then, so the xi and the a1 plus lambda b1, then we can equate those two because that's the I part and that's the I part. So since ij and k are not parallel, then x is a1 plus lambda b1. If we rearrange that, so what am I doing? Taking away x1 from both sides and dividing by b1, I get the lambda. So lambda equals x minus a1 over b1. Same then for y, which is this, and the same then for z, which is this. Because these are all lambda, I can put them equal to each other. So my equation then of the Cartesian form of a straight line is this here. Looks a wee bit confusing, two equal signs and things like that, but that's the way we sort it up. So which are the equations of a straight line in Cartesian form, and that's for a 3D one. So the Cartesian equations of the line that passes through the point a1, a2, a3 and has direction vector b1i plus b2j plus b3k are just exactly what we had there. So it's x minus a1 over b1 equals y minus a2 over b2 equals z minus a3 over b3. And all of that is effectively then equal to the lambda bit. These things, it is quite confusing, I'm sure you'll agree, but these things make a bit more sense then whenever we take a look at the examples. So let's take a wee look then at our example 1. Find the Cartesian equations of the line parallel to the vector 2i minus 5j plus 4k that passes through the point A with the position vector that. So it's parallel to this, so that's the b bit there, and that then is going to be our a bit. So if we have r equals a plus lambda b, we would rewrite that then as r equals, so where's the a bit? It's going to be minus I plus 7j minus 2k plus lambda upon the b, which is 2i minus 5j plus 4k. Rearranging this here, I'm actually going to write this as xi plus yj plus zk, and then rearranging this to the I bit. So can you see the I bit then is going to be minus 1 plus 2 lambda, and then the j bits is going to be 7 minus 5 lambda, and the k bit is going to be minus 2 plus 4 lambda. That means taking each bit separately. So I need to make sure this is always on the screen. I'm bad at that. So x is equal to minus 1 plus 2 lambda. Y is equal to 7 minus 5 lambda. And z is equal to minus 2 plus 4 lambda. Therefore, lambda is equal to, so what are we going to do in each of these? I'm going to add 1 to both sides and divide by 2, so it's going to be x plus 1 over 2, which equals, what am I doing here? Y minus 7 over minus 5. And then it's going to be z plus 2 over 4. And that then is the Cartesian equations of the straight line taken from this one here. Okay. Example 2 is a similar thing, only backwards. So I hope you can see that we are going to let lambda x minus 1 over 5 equals y plus 1 over 2 equals z plus 2 over 4. And then if we separate it out into the x, the y and the j bit, sorry, x, y and z bit, then x is going to be, so I'm going to times by 5 and then add 1. So it's going to be 1 plus 5 lambda. The y bit times by 2, so it's 2 lambda. And so it's minus 1 plus 2 lambda. And then the z part, minus 2 plus 4 lambda. To work out then our vector equation, it's going to be r equals a plus lambda b. But before we do that, we're going to go for 1 plus 5 lambda I plus minus 1 plus 2 lambda j plus minus 2 plus 4 lambda k. And then to separate it out, just fit this in here, we're going to have I minus j minus 2k, I minus j minus 2k. So that's the a bit, plus lambda b is going to be 5i plus 2j plus 4k. Example 3 just about fits in at the bottom here. I wonder if we more space on the other side. It's so we'll maybe make a start on this side and then find the Cartesian equations of the line that passes through the point 3, 1, minus 2 and 4, 3, 4. So we want effectively to try and get our vector equation of that line first of all. So we need the direction vector, so we can do this on this page and I'll go over the other side. So direction vector, how do you do that? If we do one of these, take away the other one. So I'm going to go for 4, 3, 4, subtract 3, 1, minus 2. You can do it the other way around if you wish. That'll be fine, but that's going to give us 1, 2, 6. So that's going to be the B part. So let's go then to the next page. I'll fill it in. And go up here. Therefore, vector equation, we're going to have R equals, what was it? Yeah, so I'm just going to pick one of the points. I'm going to pick 3, 1, minus 2. So this is going to be 3i plus j minus 2k plus lambda upon then my direction n was 1, 2, 6. So that's going to be I plus 2j plus 6k. And just exactly like my example 1, I'm going to rewrite this and rearrange it then and get it in the right form. So if I write xi plus yj plus zk, I'm trying to rearrange this one. So we're going to have 3 plus lambda I (1 plus 2 lambda j) minus 2 plus 6 lambda k. And then I can rewrite these in each in terms of lambda. Well, let's do it out separately first. Let me grab myself another pencil here, it's a bit sharper. Here we go. So that means my x bit is equal to 3 plus lambda. My y is 1 plus 2 lambda. And my z, sorry, is minus 2 plus 6 lambda. So therefore Cartesian equation lambda equals, so how do I rearrange that? It's just going to be take away 3, so it's going to be x minus 3. You can just leave it as x minus 3, but I do x minus 3 over 1, so just try and keep the same format. That's going to equal then, what am I going to do? Y minus 1 over 2. And rearranging this to get lambda, so it's going to be take the add 2 to both sides, so I go to z plus 2, and then divide by the 6 z plus 2 over 6. Example 4 then says the Cartesian equations of two straight lines L1 and L2 are this and this. Find the acute angle between the two lines. Here's what we're going to have to do. Change this into vector form. And then use our dot product. If you remember, our dot product then is our way of finding out the angle in between two vectors. Now it's the B part we're going to use. I'll explain that a wee bit more as we get through it. But it's the B part of the vector equation, which gives us direction, so that can tell you then the angle between the two. So let's get our L1 set up first of all. So L1, the x, remember these are all equal to lambda, so that's lambda. So times by 5 will give me a 5 lambda plus 1. So it's 1 plus 5 lambda. For y, times in by 4 lambda, so that's and then minus 2. So it's minus 2 plus 4 lambda. And then z, it's just then going to be a 6 lambda. So our equation then here, and we'll call this R1. We'll just put this in column form, sure. So it's going to be 1 minus 2, 0 plus lambda upon 5, 1, 6. So what have we done? We've changed L1 from Cartesian form into vector form. We now need to do the same then with L2. X is going to be times by 2 to give me 2 lambda, so it's going to be minus 3 plus 2 lambda. Y, 5 plus 7 lambda. Z, minus 1 minus lambda. I maybe should have let those one equal mu, I suppose, to kind of keep it a wee bit different, but that's okay. We'll be fine for that because they're not really going to be used with each other. R2, then minus 3, 5 minus 1 plus lambda upon 2, 7 minus 1. So those are now our two lines. We've changed them into vector. And so the way we're going to find the angle, so let's take this down in our notes. The angle is found between the direction vectors. So that's going to be the 5, 1, 6 and the 2, 7 minus 1. What's our dot product formula? It's A dot B equals magnitude of A, magnitude of B, cos theta. A dot B, nice straightforward one for us, so we're going to do 10 plus 7 minus 6. Have I made a mistake here? Is that a 4? That's a 4. Sorry. Right, let's go back. goodness. It's this one here. That's a 4 lambda. That's a 4. So we're okay. Yeah, so we are going to have 10 plus 28 minus 6. Sorry about that. I always make mistakes. And then here, it's going to be the square root of 5 squared plus 4 squared plus 6 squared times the square root of 2 squared plus 7 squared plus minus 1 squared times cos theta. 10 plus 28, 38, take away, so it's going to be 32. So to get the cos theta on its own, 32 on the top, and then 5 squared plus 4 squared plus 6 squared gives us 77. So that's going to be the square root of 77. Just leave it as that, that's fine. And then 49 plus the 4 gives me 53, 54. So it's the square root then of 54. I put that number into my calculator. I hit shift cos, and it gives me an angle then of 60.2 degrees.